Mahajan, who is a senior mechanical engineer at KPM Engineering Consultant. He has a rich educational background and a master's in project management degree. Apart from that, he has completed various certification courses related to the field and is affiliated with various professional organizations and institutes. Mr. Mohit is leading MEP and infrastructure projects. He designed mixed-use developments, hotels, and high-rise buildings. His core design values are energy and climate, water and wastewater management through an integrated and sustainable design process. He has worked with clients such as Tata Housing, Nesco, Lodha, Reliance, ONGC, and Tata Power, and he is passionate about sustainable and simulation-based energy efficient building design. Today, Mr. Mohit will talk about the future of HVAC systems with AI. So delegates, let's welcome Mr. Mohit.
So basically, we right now, Mahesh already explained about with the example about the artificial intelligence. So that example, when it comes with the particularly with respect to, I'm going to give more insights basically with respect to MEP, and out of which MEP HVAC is the one of the main part, which approximately 40% of your energy consumed with the HVAC system. So we will go with in detail with the HVAC system, future of HVAC system with based to AI. So going forward, then basically when we design the HVAC system, so our main concern and traditionally what we have done, we design the particular as per the requirement of that particular building or any type of building. So we design particularly HVAC system, and then but we are conventionally doing that design. But apart from that design, we need to change the some with respect to the automation, because in the era of that particular digitalization, we need to go to the upgrade our systems also with respect to the digitalization. So even though Don Sinerby also said that you can be content with the status quo or you can choose the revolutionize it. So basically we want the revolution because we want that particular with respect to even though our PMO also said that in order to reduce the carbon footprint and all these aspects which we already committed by our PMO and COP26. So particularly in order to achieve that, in order to reduce all the carbon footprint, and we need to think it with respect to that how to minimize the energy, so we can go ahead in that direction. So particularly when it comes to the HVAC system, so conventionally if we consider any commercial building, if we are taken an example of commercial building, we have the particular system with the multiple components. So multiple component, when I'm saying, so we have the plant room, then we have the particular plant room along with the to particularly take care of that your entire building system's requirement. So when we say the entire building system, there are multiple your offices or multiple back of the offices and your maintenance teams offices. So when we take care of that particular offices, we have the air handling units at respective locations. Then air handling units along with that particular when downside ducting is there. So there is a multiple automated part, particularly we can say that equipments and the peripherals, we can say that, or actuators, then your sensors. So particularly in that case, so in order to particular design development, and we need to along with that when we need to align it with the AI. So when we say AI, it's a cognitive artificial intelligence to be drive based on the model-based predictive control system. So when I say control system, so it relates to your energy. So how we can relate to its energy. So basically, so it demand control ventilation will will minimize your not minimize. We can say that it will be based on your actual requirement of your fresh air. So when we say that because occupancy is the one factor which is changing based on the requirement of the tenant or the client requirement. So that will be go on changing, and that based on that your requirement, based on that requirement changes. So occupancy changes, your temperature basically and the controllable parameter based on your tenant requirement. So temperature and humidity we can decide based on the client requirement. but the temperature and humidity outside outside the building, which is uncontrollable parameter, that is, we can say that weather condition. So here, so basically our majority of the particular controllable parameters and uncontrollable parameters, which we need to take care. That particular parameters we need to link with our particularly system, and that's linking of that system along with the earlier in traditional way we do that particularly with respect to controllers, sensors, based on that sensors and controllers. So here also we are doing it with the help of controller, but we are doing it in the smart way here, where we have the database system, where we are going to give the continuous feedback on that particular database. If we have done the one of the operation, that operation will be saved in that particular brain of the system. It can be used multiple times, and where if any failure condition also happens, then that also be recognized by that brain. So that will be entirely your system based approach. So here we can say that so multiple controllers and the system will, along with the interconnections, that will be assisted to the HVAC control. We can say that us particularly when we go to the particular database system. So when AI works with the HVAC system, there is a special in that case, when we say that particularly, when I say that but system need that particular operations, so that special class of AI techniques called the deep reinforcement learning. So deep reinforcement learning that particularly deal with your operations day by day, and which is stored in the form of stored in your database. Whereas in conventional, we have the particularly rule-based approach. Whereas in AI, it's a non-linear contract type of approach, where in which when the DRL is basically the technique is where that agent is trained by intersecting with the multiple environment, learning from that their own success and mistake, that is going to store in that particular system. So successful application, and along with the deep learning, has always been limited by lack of good quality data. So DRL is not having that particular limitation. So DRL can work. It learns to control the system. So particularly DRL agent interacts with the interior particular interior, we can say the indoor air quality and that all the temperature, humidity parameter, all these parameters, environment, while trying to these particular controllable parameters and uncontrollable parameters, which we seen in the last slide. So particularly that we will get action in the perform, and this gives the ability to test, optimize, to particular that base level. So control strategies can be defined, and that can be based on the requirement of human comfort. And then again, the particularly when we say that this is our HVAC requirement, which then again encode with the domain specialist, that for that matter we require that particular programming expert, then knowledge, and that so that can be simulated in environment. And the same way in the reward function to get the particular data from the DRL, and the DRL itself we called as the agent towards the expected performance. So for the instance of multi-objective problems and the particularly reward to agent. So in that particular case, so HVAC system is an excellent target to control with the help of DRL. So to optimize the control, we particularly here we can say that with the help of AI, so we can optimize the better way from the traditional to our with the help of AI, artificial intelligence, we can control the entire system better than the traditional way. So going forward, already we can say that particular even the Mr. Mahesh already explained about the design process. But while doing that, we can take an example. If the retrofit, if we have the particular major area of the our commercial building is going to go with the retrofit job, and that for that particular retrofit, this is the old building and we need to do the retrofit of job, and we have that particular having that earlier design is having the most means they are not we can say that now the change in the particular technology which give the better efficiency. So while and to execute that particular job we require at least the means project duration is the time frame approach particular for that particular project. So in that case, when we say that we can design, we can create that particular model, and we have the historical data. So means while doing before the execution, we can do the testing hypothesis, and we can plan the strategies using the AI. So in particular model, we can call as a digital twin, where we can sync it digital twin with the AI agent. So AI agent is nothing but the DRL, which we are already explained earlier. So in which but we need to add this particular historical values. We can say that we have, it's a retrofit job. We know the how the external parameter will be there, how your client requirement with respect to temperature, humidity based on the codal requirement and the respective areas. So in this particular detailed building model, we can calibrate with the historical energy consumption, and even in that case, designer can test the various scenarios and stimulate the entire load of that particular bit. So simulation will help the designer, even client, and the for the optimization of cost and the even the future. We can say that future operations, where in which they need to analyze the how much in their yearly energy consumption, how much their, we can say for the if are based on the ROI calculation and all the system, if the space is tenant base, and so we can do the multiple exercise, even though at the design level only. So it offers to make the educated, so data-driven decisions we can take, and not rely on the only on the experience. So that's the main key feature of that particular hypothesis, testing hypothesis and strategy. So then going forward, that particularly exact, we can say that when we create the particular model, or then we can equation in which particular model that we can train the deep reinforcement learning agent to obtain the optimal HVAC control. So this particular case, we can deploy that particular control. So when we say that control based means in AI, we can use the AI agent to control the particular actual building system. Means even though we have not constructed that particular project or building, so we can think about that particular how we can optimize their operational cost. So that's the key feature of that particular. Means create a model, then emphasize your all parameter, check how your building will perform, and you can understand the your requirement. So then on that basis, we can take the key decisions. That's the key feature. Then we will go to the particular next from. So what's the, when we use that particular along with the AI operation and the manual operation. So these are the main things. The base case, when I say the manual, earlier case, we can say that a manual adjustment, temperature, ventilation, and other parameters we consider to achieve the desired indoor environmental comfort. When we say the AI-based case, in that case, we are basically adopting changing means particularly AI technologies to adopt the changing scenarios. Particularly when we say changing scenarios, our external temperature is going to change now day by day. So this we can think by using artificial intelligence, and we simulate it in a better way. So here in the conventional, we cannot analyze the entire particular model based on your earlier requirement. Means here we can do that. We will get the quick response based on your means we can plan that control mechanism with respect to that. Then your non-linear control techniques we can develop, and distributed, particularly when I say distributed AI in devices. So you are right now that Modbus, I think Modbus system and that particular peripherals, that is your T plus RH sensors, then your CO2 sensors, all your control valves, and then your particularly dampers, which dampers and actuators, so that Prakash will give that emphasize on that particular system. So going forward, so that we can, that control distributed end devices, we can club it with our requirement, and that we can analyze it with the model. Then when we think of the from hardware setting to HVAC control, when we think about that particular change, even though our building having the 30 to 40 years of minimum life cycle, even though we are thinking of the particular change in our system, so in base case it's not possible to do all these things. Base case you have this present number of parameters with the means we have preset number of parameters. In AI base you have power of AI is not only the sensor and that particular operate behind them. So particularly not only the peripherals and at that connection, but in your AI based application you need to think what you want, and that based on that you need to create an algorithm, and that algorithm and their so based on that algorithm data sets which we can present, depending on data sets we can model it, and we can do whatever we require that can be achieved by using the AI controls. Going forward to the reactive to predictive maintenance, which is already particularly covered by Sumahesh, but even though with respect to HVAC, so I can say preventive and reactive, nothing but same, but in which this is a conventional method where the preventive we can a traditional system where we can say that when our failure occurs, we can say that based on that industry practice we can say that after 3 months. So based on the manufacturer's recommendation and all these things, the maintenance can be planned. But in the case of predictive, you have the tools in place, the peripherals in place, and the particular brain behind that is in place. So that particular workflow will be set to realize the particular your system efficiency. And then when we say the system efficiency along with your life of particular equipment. So and how equipment is performed. So particularly performance of your equipment, then your analyzation of their output of parameters. So when we say that if the motor particular, we can consider example of motor. So how much of voltage, current, and all these things when we check in the predictive maintenance, same can be analyzed at the each and every day. With the, we have the log of particular every minute of actions, and so even though if any particular change in the particular working there, so that particular facility team can get the data that also something means particular equipment is not going to work in their proper way. So we need to take care of before doing it any failures. So your failure lead to the downtime. So that will help predictive maintenance to the facility team. And along with that, your further steps also we can avoid. So that's it with respect to HVAC, and thank you.